Hello and welcome to my channel Data Analytics with Ashwini. Preparing for data analyst interview? Master these 5 SQL queries you will use again and again in real world analysis. Let's get started. For today's examples, we will be working with retail sales database called DB Retail. It contains 5 tables: customers, orders, products, returns, and salespersons, which are connected through relationships. We will use this real-world style dataset to solve 5 practical SQL problems that data analysts might encounter. Let's start. First business question. How much revenue has each customer generated? In line number 6, I am calculating revenue using quantity multiplied by selling price, and then I am applying the discount. Because I want one result for each customer, I am using group by customer ID at line number 8. In line number 6, sum calculates the total revenue for every customer. Finally, at line number 9, I am sorting the result in descending order so that highest revenue customers appear first. This is the most important SQL patterns for a data analyst: group by plus aggregate function. Let's run this query and see the result. Here we can see customer ID, which is available in the select statement, and total revenue, which we have calculated using this sum function, and then we have applied the discount. Second business question. Find customer name, total orders, and total revenue. Now let's make the question more realistic. Instead of only seeing customer IDs, management wants to see the customer name, number of orders, and total revenue, which we have calculated in the first SQL query. The customer information is in the customer info table, while the transaction information is in the orders table. So in line number 9, we need to combine these two tables using an inner join. In line number 10, we join them using customer ID because that column exists in both tables. At line number 6, count gives us the number of orders, while at line number 7, sum calculates revenue. Finally, at line number 11, group by customer name gives us one row per customer. This type of SQL query is extremely common in real data analyst work because business data is usually spread across multiple tables. Let's run this query. You can see customer name, which we have used in select statement. Count distinct of order IDs as a total orders in the second column. And in third column, it is showing the total revenue which we have calculated in our previous SQL query. Third business question. Suppose the company wants to classify customers based on revenue. Now let's add some business logic to this. Here we are using case when to convert a numerical value into a business category. If customer revenue is rupees 25 crore or more, it's high value. If it's rupees 10 crore or more, medium value. If it is less than 25 lakhs, low value. Otherwise, we consider it as very low value. Case statements are very important for data analyst because SQL is not only about retrieving data, we also use SQL to create meaningful business categories. So let's run this query. You can see customer name, total revenue, and customer categories are divided into high, medium, and low categories. Fourth business question. Now let's move on to the more advanced and very common data analyst interview question. The business wants to identify the top 3 customers by revenue in each region. Notice that this is not simply asking for top 3 customers overall. We need the top 3 customer within every region. Step 1. First, I need to calculate total revenue generated by each customer. Our customer information is available in customer info table while transaction information is in the orders table and the product selling price is available in the products table. So I am joining these three tables using customer ID and product ID. To calculate revenue, I am multiplying quantity by selling price and then applying the discount. Because I need one revenue value for every customer, I am grouping the data by customer ID, customer name, and region. I am storing this result in common table expression called customer revenue. Step 2. Now we have total revenue for every customer. The next step is to rank these customers within their respective region. For this, I am using row number window function. The most important part here is partition by region. This tells SQL to start ranking separately for each region. Then I am using order by total revenue in descending order, which means the customer with the highest revenue will get rank number 1. Step 3. Finally, I select the customer details and filter the ranking using the where revenue rank less than or equal to 3. This means we only keep customer whose rank is 1, 2 or 3. And because the ranking was created separately for every region, we get the top 3 customers from each region. Finally, I'm ordering the result by region and rank. So the output is easy to read. Let's run whole query. You can see the output: customer ID, customer name, region, total revenue, revenue rank. If you observe, in central region we have rank 1, 2, 3. Same in north region, same in south region. One important interview point here is why I am using row number instead of rank. Row number gives every customer a unique position 1, 2, 3 and so on. Therefore, where revenue rank is less than or equal to 3 gives us exactly 3 customers from each region. However, if the business requirement says that the tied customer should be included, then we use rank instead. For example, if two customers have the same revenue and both are in third position, rank would include both of them. So our complete approach is: first, calculate customer revenue. Second, rank customers within each region using row number. And finally, filter for rank 1 through 3. This is very useful SQL pattern for questions such as top 3 customers per region, top 5 products per category, or top 3 employees per department. If you understand partition by and Windows function, you will be able to solve many advanced data analyst interview questions like this one. Query 5. Business question. Our final question is, how is our revenue changing month by month? We want to compare each month's revenue with the previous month and calculate the growth percentage. Step 1. Calculate monthly revenue. First, I am calculating the total revenue for each month. I am converting the order date into year-month format, such as 2023-01 and 2023-02. Then I am calculating revenue using quantity, selling price, and discount. Step 2. Use lag. Now comes the important part, the lag function. Lag allows us to bring the previous month's revenue into the current row. For example, February can see January's revenue and March can see the February's revenue. Step 3. Calculate growth. Now that we have the current and previous month's revenue, we can calculate the month over month growth percentage. A positive percentage means revenue increased, while a negative percentage means revenue decreased. Step 4. When your result appears, looking at our result, revenue increased by 18.11% in February, increased again by 38.36% in April. But from May to July, we can see decline in revenue. So, with just one SQL query, we can quickly identify the monthly revenue trend. Final takeaway, the key concept here is lag. It is very useful whenever we need to compare the current value with previous value. This is why window functions like lag are important for data analyst interview. You can see the result. Sales month, revenue, previous month revenue, month over month growth percentage. February is increased, then decrease, again increase, and whenever you can see negative value, it's decline. So let's quickly recap the 5 SQL patterns we covered today. Number 1, group by and aggregate functions. Number 2, joins for combining business data. Number 3, case when for business logic. Number 4, rank with partition by for top N analysis. And number 5, lag for time based comparison. These 5 patterns I strongly recommend practicing if you are preparing for data analyst role. Don't just learn SQL. Learn to solve problems with data. Subscribe to Data Analytics with Ashwini and keep learning, analyzing and growing. See you in next video.